Another video about integrating a product. We're going to look at a particularly interesting situation here with integrating x ln x dx. Now I've written out the integration by parts formula up here, which is in the formula book, and we're going to use this technique to swap this difficult integral here for another one that we hope will be much easier. Now I've chosen this example because I'm going to show you, first time round, we're going to do it wrong, because I'm going to point out a particular little quirk of this type of integral. Now normally when we would be putting our u here, our u prime there, and our v there, and our v prime. Normally when you see an integral by parts and it's got an x in it, you'd want to choose this as your u, because you know that when you differentiate x, you're going to get 1, and you think that's going to make your life easier. Now what I'm going to do now is do it that way and show you how it doesn't, and then we're going to look at using that and how we can do integration by parts and see it give us a problem, and then we'll go back and we'll do it the correct way. So first up, let's give in to temptation. We'll make x our u, because we know that differentiates to a nice easy 1. That means we've then got to have our v prime here as our ln x. Now, we're going to be getting a bit suspicious in a second, because having chosen v prime as ln x, we need to integrate that. An integral of ln x is x ln x minus x, which ought to be ringing alarm bells at this point. Let's see if we now complete the formula, and we'll see what happens. So our integral at the moment is going to give us the left-hand side here, our uv. So that's going to get us x squared ln x minus x squared. Well, so far so good, but at this point we've got minus the integral of du dxv, which is this, 1 times that, which is x ln x minus x dx. And we can see at this point that by choosing this the wrong way round, by giving into temptation and putting the x here, we've ended up converting that integral into something that's much worse, and in fact includes the same thing again, so it's not really helping us at all at this point. So let's go back now, let's reject that and do it the other way round and see what happens there. So we are going to start with integral of x ln x dx, and this time round we're going to have u and u prime, v and v prime. Instead of choosing u as x, we're going to have ln x as our u, and that's going to give us our v prime here as x. Now to complete this, we differentiate ln x. The diff of ln x is 1 over x, and then the integral of x is x squared over 2. Now let's complete the formula for this, and we end up with the left hand side here, so x squared over 2 ln x minus the integral of that diagonal, so minus the integral of 1 over x times x squared over 2, and that gets us 1 over x times x squared over 2. I'm putting everything in so that you can see what's happening, and then we'll tidy this up in a second. So let's rewrite that in a little tidier form. We're going to cancel that x with part of the x squared there, and get ourselves the integral of x over 2 dx. Now this integral we can do, it's fairly straightforward. So that becomes x squared over 2 ln x minus, well, the integral of x squared would be, an integral of x would be x squared over 2, so the integral of x over 2 is going to be x squared over 4 plus the arbitrary constant at that point. And that then will be our integral of x ln x.